All righty. So let's start with a free body diagram, but the system is at rest. So when I draw this free body diagram, I expect that you will say, okay, 60 newtons here and tension here, and those arrows should be the same size. Net force is 0. They said just before it begins to move. Over here, I will have 100 newtons there, tension here, friction here, and they should be the same size, normal force here. Any questions about this drawing? You should use a ruler on the test. Now, net force is 0 in this problem. So it's pretty straightforward. I can say that although I'm going to choose this way as positive because the system will move in a bit. That choice doesn't matter that much because the net force is 0. But I have 60 minus tension equals 0 here, so the tension equals 60 newtons. Over here, I have normal equals 100 newtons because normal equals the weight. I also have tension minus friction equals 0, so tension equals friction. But I was just told that the friction is 60 newtons, or at least I just figured it out. So I can go one more step and say friction equals 60 newtons. The question asks, what is the coefficient of friction and what type of friction is this? Well, this is static friction because the system's not moving. And although I've not talked a lot about that in this class, it's not hard to figure out whether we're talking static friction or kinetic friction. If it's moving, it's kinetic friction. If it's not moving, it's static friction. Be aware, though, that doesn't mean static is always, doesn't mean that kinetic is always net force equals ma, because you can have kinetic friction and the object can be moving at a constant velocity, and that would still be kinetic friction, not static friction. But static friction, net force always equals 0, period. You want to make sure you memorize something. That's an important thing to know. All right, that being said, friction equals mu times the normal force. So mu has got to be friction divided by the normal force. I have friction, it's 60. I have normal force, it's 100. So my coefficient of friction, 0.6. It has no units. This is one of the only things that we measure in here that is a unitless quantity. All right, question number 2. The mass is given a small tap, and suddenly the frictional force changes from 0.6 to 0.4. That's going to change everything. It's going to change the tension. It's going to change the friction. It's going to change the acceleration of the system. And I bet they're going to ask for all of that. They sure are. What kind of friction is this? It's moving now, so it's kinetic friction. So that changes the problem. We have to kind of reformulate what we're going to do. Not very much, but from now on, the system could be accelerating. We don't know if it's accelerating, but it could be accelerating. The 60 newtons doesn't change, but the tension is suddenly reduced. I expect I could ask that question without having you work it out. You should know that the tension is reduced because the system is going to accelerate downwards. So the forces have to be unbalanced. I'm hanging a weight that hasn't changed, but now it's accelerating downwards. The only way that works is if I reduce the tension. So be aware, that kind of question, I'm all in on. The tension here also will have to be reduced. I think it's fair to say that because the coefficient of friction changed, the size of the frictional force has also changed. And you're not asked to redo your free body diagram. I am just being thorough in explaining this to you. And although nothing has changed in the y direction, T minus F now equals MA. So I have two force equations with 2 unknowns. Oh, unfortunately, there's 3 unknowns. I'm going to have to walk the line of friction again. Friction equals mu times the normal force. They gave us the new coefficient of friction as 0.4, and the normal force hasn't changed. It's 100. So friction has become 40 newtons, not 60 newtons like before. Any question about that, guys? All right, that's basically it. So I got T minus 40 equals 10A, and I have 60 minus T equals 6A. These are my 2 force equations. They are what I'm going to use to figure out the acceleration, which is question B. I'm going to add those together and get 60 minus 40 equals 16A. So A is 20 over 16, or what, 1.25 meters per second squared. That is the acceleration of the system. So to figure out the tension, I'll put that back into one of these. Figure out the tension. I don't care which one you put it back into, but you need to put it back into one of them. I'm going to put it into the top one because I'm multiplying by 10. That's easier. So to find that tension, I'm going to say, there, just move that over there a little bit. I'm going to go T minus 40 equals 10 times 1.25. That's going to be T equals 40 plus 12.5 or 52.5 newtons. That's the tension. I could plug it into both and check my work. You guys who have maybe some, sometimes spotty algebra skills, it might be in your best interest to check your work. All right, that's problem 1. Any questions? All right. Well, oh, wait, there's something in the chat. I'm not even looking at the chat. Sorry. Wouldn't the 5 kilogram box pull the 2 kilogram box up? That's a long time ago. So yes, I think so. Sorry, dude. I'm not looking at the chat. You guys got to speak up, okay? There's already enough screen stuff going on. All right, so I'm gonna go to the next problem. Boom, here. I do want to call your attention to this disclaimer down here at the bottom that I put out there. Did you read the disclaimer? Just because your practice test didn't have an inclined plane doesn't mean I can't provide one on the test. So, keep in mind, there's no reason. Okay? I just didn't have one on this practice test. I can't put every possibility of a problem on the practice test. You have a limited amount of time. So if I'd put it on there, some of you would have done it, some of you wouldn't. And all I'd be doing is punishing the kids who probably would get the questions right on the test as it is. So your practice quiz from yesterday had an incline on it. That should clue you into an incline could be on your test. All right? So without any further ado, let's take a look at this problem. And I got 2 boxes on the surface, and they're being pulled with a 200 Newton force to the right. What is the acceleration of the system? Well, it's a train question, but look, we've talked a little bit about these train questions. When I see this problem, I could just say net force equals MA. 200 newtons equals 100 times A. So A has got to be 2 meters per second squared. You could do that. It's a system. But I recognize that might not be what you did. So let's consider that there's a 200 Newton force this way and a tension this way. And yeah, up and down forces too, but there's no friction in the beginning. So I'm not going to worry about the up and down forces yet. That also means that this box is experiencing a tension this way, and that's it. So net force on the 75 kilogram box is going to be T equals MA. That's this box. Just out of space. Net force on the 25 kilogram box will be 200. I got 200 going to the right, minus T. T is going to the left. And that equals 25A. That's this box looking at the forces on that box. How we doing? All righty. No questions is either good news or terrible news. Add these two together, the t's cancel. I get 200 equals 100a. So a, again, is 2 meters per second squared. Yay. Question B, what is the tension in the string between the blocks? I'm thinking there would be the right place to do that. So tension equals 75 times 2, or 150 newtons. We good? Question C, if the blocks suddenly encountered a section of the surface where there is a coefficient of kinetic friction of 0.4, would this change the force between the blocks if you continue to pull with the same force? Interesting question. I don't know that you can answer it qualitatively without doing a little work. You could try, but I think you're probably going to have to do some work on it. So let's consider that I don't know the answer to this question, but I could find out the answer to this question. Bless you. So we know the original acceleration was 2 meters per second squared, and the original tension was 150 newtons. Let's tuck that away. And let's change the problem to include a frictional force that acts to oppose the motion of the blocks. Now, this frictional force acts the same way on both blocks, so it's unlikely to affect the tension. But I think it's worth proving it. More importantly, who knows what your test is going to ask? Well, I know what your test is going to ask, but you don't. So let's consider that there's a weight downwards, 750 newtons, and a normal force upwards. Let's consider on this one, there's a weight downwards, 250 newtons, and a normal force upwards. And now let's take a look at box one, or sorry, the 75 kilogram box and the 25 kilogram box. We'll look at them separately. Normal force equals 750. Tension minus friction equals 75A. Friction is 0.4. I'm sorry, the coefficient of friction is 0.4. So friction equals 0.4 times 750. I think that's 300. Is it? Yeah. All right. So tension minus 300 equals 75A. I'll tuck that away for a minute, but that's the work that has to be done. Let's look at the 25 kilogram box now. I've got 200. Well, no, let's talk about its normal force. Normal force equals 250. And 200 minus tension minus friction equals 25A. I'm going to have to get that frictional force again. So we're going to use the friction equals mu times the normal force. 100. Excellent. So friction is 100 newtons. So that means 200 minus tension minus 100 equals 25A. I have two force equations now. Can add them together to get one force equation that has probably my acceleration in it. So when I do, the tensions cancel, but I get 200. I get 200 minus 100 minus 300 equals 75A plus 25A. Tensions cancel. And A equals -2 meters per second squared. How are we doing there at home? Any questions yet? All righty. To figure out the tension, I got to plug that in someplace. So to me, the best place to plug it in would be right there. So T minus 300 equals 75 times -2. That's going to make -150, move the 300 over. So T equals 150 newtons. It's the same. Now, is this the same as a coincidence? I don't know. Maybe. But I'm not sure you can answer the question without doing this kind of work to check. All right. This has been fun. I love doing these problems. No, I don't. I'm so bored of this stuff now. Been doing it in mechanics too, so I'm just getting tired of it. The blocks are now picked up using a different force. If you wish to maintain the acceleration found in part A, what would the force be to accelerate the system upwards? All right, so I am pulling on the blocks now this way with an unknown force. It's a question mark, but the system's going to accelerate at 2 meters per second squared. So, I mean, we could, again, cut to the chase and consider that that force has to accelerate a 100 kilogram system. And although I don't know what the force is, I know that the acceleration has to be upwards at 2 meters per second squared, which means I need to pull with a 200 Newton force. Questions?
I had one question. Since you're going to be pulling it up, wouldn't it the force you'd require be greater because now you're having to act against gravity more, right? I don't know.
I was hoping I'd get somebody to speak up. You guys have been so quiet. This is all wrong. Every bit of this is wrong. So I was hoping somebody'd speak up. It's good to see you guys are actually paying attention. Thank you, Nathaniel, for pointing out that, yeah, you can't do it this way. This is wrong. So let's do it right. We can still treat it like a system, but because it's vertical, the forces have to include the system. So if I treat it like a system, I will have my upward force, but I will have weight downward, which is 1,000 newtons. I can still treat it like a system, but I have to treat the whole system together, which would be F minus 1,000 equals 100 times 2. So F is going to have to be 1,200 newtons. This is the helicopter problem from a long time ago, or the elevator problem from a long time ago. Now, I tend to believe that you guys will resort to doing the problem the way we've talked about it in class. So although this is cutting some corners, it does work faster. You probably will be people of habit and will do the problem in parts, which I think is fine because we need to do that anyways for question B. And I'm going to force you to do it this way anyways, because I'm going to ask question B on the test. Yeah. It doesn't ask for anything besides that. So yeah. But I would bet on your test, there's going to be some more explanation things going on. So if I consider the 25 kilogram block, it's going to have an upward force, a downward tension, and a downward weight. Oh, I'm sorry. I'm looking at the top blocks. So this is 25. So the weight's 250. And the system is accelerating upwards at 2 meters per second squared. So F minus T minus 250 equals 25 times 2. Net force equals MA. Cutting some corners because we are shorter on time. Now, keep going. Look at the 75 kilogram block. I will have tension up and weight down. So I think the tension is going to have to be greater than the weight for it to accelerate upwards. So I'll have tension minus 750 equals 75A. Now I add these two things together and the tensions cancel out and I get this right here, T minus 750 equals 75A. So just, well, 75 times 2. So I'm just taking this and writing it here so that I can add them together. And when I do, we get what we had just a moment ago, which is force upwards minus 1,000 equals 25 times 2 and 75 times 2, which is going to be 200.
Mr. Shelton,
Yeah.
what about the normal on the 75 kilo box?
Is it in contact with any surface?
Yeah,
What surface is it in contact with?
the floor.
I don't see a floor here. They're picked up. Floor would have to, I mean, I would have to draw the floor in for there to be a floor here. So I don't see a floor here. I mean, it also says that they're accelerating upwards. So, yeah, no. Sorry. So force equals 1,200 newtons, like we thought. But doing it this way gives us the ability to figure out what the tension is. We don't actually need this 1,200 to do the tension, though. Tension is right here, 750 plus 75 times 2, which gives me a tension of, well, that's 750 plus 150. So is that 900 newtons? There we go. My head might be in the way, though. I would say if you can do all of these, you're probably getting a middle to a high B. No. Sorry, dude. There's a lot going on. And I tend to favor, this was last year's test. I tend to favor problems that have expressions. I think that these are good things that you should be able to do. All of this will be on the test. I think that you're probably going to have questions that require a little bit of explanation too. And there's been no explanation here, but I think you can expect that. These problems were not more difficult than your quiz from yesterday. They're the same level of difficulty. So that's why I would say this is the same kind of problem. But you remember, there's also going to be multiple choice. You guys are terrible at that. I mean, you guys know that. So I would refresh your memory, maybe run through the chapter a little bit, know your vocabulary. But I would also recognize that you are easily tricked. I mean, I know that I can trick you with the bug in the car. You're easy to trick. So you should, recognize that you have to make it through the multiple choice before you even get to this problem. And we've been batting about a 60% on multiple choice. So you said, if you want to get an A on the test, well, you're going to have to improve your skills on multiple choice probably if you want to get an A on the test. There will be about 15 multiple choice questions, one short answer question. I say short answer, but it's probably going to take about as long as one of these. And then there'll be a one of these. So the short answer ones, you have to explain yourself, use of vocabulary. And we know that you guys have some issues when it comes to use of vocabulary. So this test, we need to feature some of the vocabulary from the unit, which means I'm going to have to hear you talk about the coefficient of friction. I'm going to have to hear you talk about internal third law forces, be able to express what those third law forces are, be able to discuss that forces come in action and reaction pairs. These are all conversation elements that we had through the course of this unit. In the verbal part of the test, I think you guys are going to have to be able to talk to me about that. That's what's going to take to get an A. I don't mind having the threshold to get an A to be higher than this. I think that's appropriate. So some of your homework questions were probably of too high a threshold. Not because I didn't think that they were appropriate, but because they would take too long to be on the test. That's why they can be in the homework. So I think most of your questions are going to be two-body problems if you're dealing with, or no more than two-body problems if you're dealing with inclines and coefficients of friction. I think a three-body problem can be given to you as long as that three-body problem is designed in such a way as to make it not terribly time-consuming. For example, I think an appropriate three-body problem could look like this. Oops. I think this is an appropriate level three-body problem. It's not much different than the problem we've already done with an object on either side of a pulley. This is kind of the same. But I think this is an appropriate level question for you guys. Three objects, three different masses. I don't even think it'd be too crazy for there to be a coefficient of friction up here. So, that kind of thing. That's maybe max. But I would expect that you will have to be able to do on your test, although there will be multiple versions of the test, you should expect that you will have to do a problem that has an inclined plane on it. So you'll have to do your trig. You should expect that you're going to have a problem that's going to have a multi-body system. And you should expect that you're going to have a problem that's going to have the coefficient of friction where you will have to use it in some way of solving your problem. Any other questions about the test? Yes, ma'am.
The free body diagrams, what do you want on them? Is it just numbers or do you just want the?
Because you're new. So what I want on free body diagrams are clearly labeled vectors that have the letters for the force that they represent. You won't have a problem if you put the number that the force represents, but I would encourage you to put the letter that the force represents. And generally in my tests, I'm pretty clear about the free body diagram not having components on it, so that if you're going to have to do work on it, because perhaps there's a force at an angle, that should be done separately someplace else on your test. All right, so as you guys know, and I want to be very clear about this, I do not want to collect paper tomorrow. Okay, you guys are icky and you know it. So, or at least I think you're icky. So you guys who have traditionally had issues in the past with uploading your test, we want to try and make sure that we resolve those as best as possible tomorrow. Although I am required to take your paper, you should understand that I do not want to touch your paper. So if at worst you have to step out in the balcony in order to upload your document, let's hope that that's at worst what has to happen tomorrow. There are multiple versions of the test, but because of how I have to send it to folks at home, those versions will be wrapped up together. Unless I separate people out into groups, because there are a lot of people at home. So I haven't decided exactly how I'm going to do that yet, but the test will be sent out about 10 minutes before the class begins. So people at home have a chance to print it out. You will have a printed version in class tomorrow if you are attending class. However, everybody will be submitting their exam through Canvas. And because you guys are the last class to take the test, you are capable of taking your test out of the room with you after you finish it, as long as it has been submitted to me first. You guys at home, the testing window on the test closes immediately after the test. Immediately after class. Remember, this class has an extra 10 minutes added onto it for announcements. So you need to really be done by 10:15. I will probably give you a 5-minute grace to get you to 10:20. But ultimately, I need them uploaded by then. If yours comes in late, that's going to look sus. And I'm going to think you're doing something to get away with it. Unless, of course, you have a 504. If you have a 504, you have whatever time you need to complete the test. Any questions about tomorrow? All right. Well, that's all for today. We are done with class for the day. We're just now waiting on them to tell us what's going to be on lunch because we know how important that is for our well-being.